Thing on your camera. I know you don't want to ruin your beautiful Mac, but I have some of these over here that could block your camera. So it's always good to block your own camera. If you need it, actually I got stickers. If you guys want to grab some stickers, feel free to come down to get it. I know you're comfortable in your seats right now. So, okay, so let's get started. Let me just time myself. There we go. Okay, fraud. Did you know that in Canada, actually, maximum you would pay is actually $50 if there's a fraud on your credit card? Canada actually protects you in that. And with the banking system and everything else, it protects you. How many of you knew actually it was maximum $50? One? Okay. Now you know something new. Okay, so it's more the country and how the banking system works, and actually tries to protect us as consumers. So we feel protected in some ways. I like to talk about Turkey, which is Turkey. Actually, in Turkey, they don't call themselves Turkey; they call themselves Turkey. Another fact. In 2016, actually, 1.4 gigabyte of data compressed of like 50 million people were actually spread out. So you can actually find all users' information of like a citizenship, their ID number, their addresses, and everything else in 2016. So this is what happened over there. I am a Turkish citizen also too. I actually downloaded the database and I tried to look for myself. I didn't find myself because I live in Canada, so they had a separate database. Thank God for sharding. But I did find because my wife is Turkish, so I did find her brothers and sisters and everything. I didn't find my wife in there, but I did find her brothers and sisters and all their family information, their identity number, and all of that stuff. Actually, I could find it. So it was fun to actually look at a database that you're not supposed to look at, but anyways. So data breach, basically. What does data breach actually causes in us? Basically? I find when I go visit Turkey, it's a societal change in some ways. What I mean by societal change is like, I went and purchased a TV over there. And actually the guy was putting in the thing, like just in Canada, you just give your credit card and you're done, right? Gave him my credit card, but now he's like, okay, what's your phone number? I gave him my phone number, and then he's like, okay, there's going to be an OTP coming to yours, so that I could punch it in and say that I am selling to you, like the television. I was kind of like mesmerized and like, what do you mean? Like, I mean, I gotta tell you like my number is 56341. Like, what's going on? He's like, the system does not allow him to continue on unless I actually give him the OTP, even for ordering something, which was very strange to me. It's just a TV. Like, what's the big deal? But that's a societal change because there's no trust anymore. They don't trust who you are, even though they see you, but they'll say that, okay, can I get this OTP? And even for delivery, they were doing the same thing. And you have to sign twice to actually, after you give them the OTP, you have to sign twice to say that I have received the television. So it's a fraud that actually changes the society. Something that to think about. And what is the price that we're really paying for it? Like, okay, credit card, a fraud, the bank is protecting you, you got back your money. But now your data is out there. What's gonna happen? Can you get paid for it? That my personal information got stolen somehow? Who's paying for this? Like, I don't think any of you would like the fact to have your information out there and you're like, what's going on? Somebody could actually query this database and find out all the information about me. And why? Because I signed up for some service? Doesn't make sense, right? And the data is already leaked. Okay, a little bit about me. My name is Taswar Bhatti. I work as a system solution architect. I work for a company called Gemalto. I don't know if anybody heard of Gemalto. Okay, great, thanks. But now it's actually Thales now. Anybody heard of Thales? Okay, more people. Okay, great. So I don't know Kung Fu, but I do speak quite a few languages. Oh, there's one guy who knows Kung Fu over there. So that's my website. Thales actually has an office over here too in Montreal. It's called the Digital Factory. They do a lot of AIs and all that stuff. Actually, a lot of stickers are from there too. So if you're interested, let me know. If you're in AI or security, let me know. And they're always hiring more people. So I'm kind of like new. Anyway, the agenda for today is Hashicorp World. We have Hashicorp guys over here. Thank you. They gave me stickers, so feel free to grab more. What are secrets? Desired secrets, secret management, what Vault actually does, the architecture of Vault, how it actually looks like internally. I'll talk a little bit about Shamir's secret sharing, how actually what Hashicorp actually encrypts its information, policies, dynamic secrets, wraps, wrap tokens, Kubernetes with Vault, and a demo. I have one bad news, is in like I couldn't get my GCP working properly, but I have another demo that I'll try to show for dynamic secrets. For some reason, I had some permission issues that it wasn't working with my key store inside of Google for some reason, and it was working and then it stopped working. So I'll just show you a demo that's working on my machine. Works on my machine, right? Yeah. So what are secrets? So secrets are basically, it grants you authentication and authorizations. So these are like facts of like authentication and authorization to a system. So what does an example of that would be like username and password is a secret. The database connection string, for example, the API token that you might use to consume another service, the TLS certificate that you might have. So how many of you think that your address is a secret? Great, nobody thinks that. So it's not really a secret. Because even if I have your address, I don't have a key to enter your home. The key is more of a secret, because if I have your address and the key, it's a combination of it, then it's actually a secret. That you want to save your key, you don't want to put it anywhere. So that's more of a secret than a information of yours. Or even your birthday, that's not really a secret. So what the secret allows you to do is basically to enter doors. So it will allow you to actually enter to a system or anything else. So what are we living at today, basically? Today we have something called secret spoil, and we have secret ends up everywhere. It could be in the source code, it could be in your version control, your GitHub or Bitbucket, whatever you want to use, your configuration management. It could be in your Chef, your Ansible scripts and all that in order to log into some other system. So what are the issues with this? Basically, how do we know who has access to that secret? Like, it's in your source code. When was the last time somebody used it? I mean, we don't know. Like, somebody had that secret and logged in. How do we know when was John who actually got that secret and logged in? If you want to rotate the secrets, what happens? If you want to change it, do we change it in all the source code? We have different microservices. Do we change it everywhere? So what is the desired state for secrets? It has to be encryption in rest, only decrypted in memory. There has to be access control to it. And there has to be rotation revocations. Basically, you should be able to rotate your secret keys in some ways. So Vault is the solution for this. Basically, it is a secret management for managing your secrets. So what does it do? Basically, it's centralized secret management for you. Encrypts at rest and in transit. It leases and renewal of it has leasing and renewal of your secrets. It also have ACLs, access controls, audit trails, which we talked about earlier, audits, we want audits. Multiple clients auth methods. So you could actually have LDAP integrations or Active Directory integrations into Vault so that you could actually find out that John did log in at that time and he doesn't need a different password because he has AD integration into it. Vault has AD integration into it. It also provides something called dynamic secrets, which I'll show a demo of it. It also encryption as a service it provides. And the main things it actually provides is the AES 256 with GCM encryption and TLS 1.2. And the main thing is you don't require an HSM. Even though me, Gemalto, and Telus do make HSM, but Vault does not require you to use an HSM at all. So here's the architecture of Vault. In some ways, it's like you got the API on top, and then you got the whole Vault in there, and then it always uses some kind of storage to store this information of like your configurations or your secrets and stuff like that. It needs to store somewhere, right? You can't just run it in memory. So if we break it down, the Vault part into it, so what are the main components? There's a token, there's a core of it, there's a policy, there's a routing path. Everything in Vault is actually part of our routing path that you actually provide. There's a secret engine. You could have multiple secret engines. You could have, there's authentication, there's system built in, and there's audit into it. And it all backs up to some kind of a backend. You could use MySQL, you could use Postgres, you could use MS SQL. There's all kinds of Google Cloud Storage too. You could use Google Cloud Storage for it. So it provides all kinds of backends for it. So secret management. Vault requires Vault requires an encryption key to encrypt. So you're like, okay, now Vault requires an encryption key to encrypt. Where do I store my encryption key to encrypt the information that I need to encrypt? So it's a chicken and egg problem. So what it actually does is something called Shamir secret key share. How many of you know Shamir? Okay. Okay, not in first person, but you know the algorithm. So most of you might actually know this. It's a master key that is split into multiple keys. So this is kind of the idea of it. So when Vault starts up, it spits out 5 keys. And then using the combination, you could say, okay, I pick key 1, key 3, and key 4. And then it would actually tell Vault that here's the 3 keys, and would mix them up and then create a master key for you for your encryption. So it's kind of like the 2-man rule. Basically, you need to have like 2 people in order to open up this lock right here. Like, it's not like one guy could just open it and then like there's a gun inside it and you could shoot everybody. You need a second person to open it up so that it's like, yes, we want to open this up because of whatever reason. So that's the kind of analogy of it. And sometimes it's like in movies you might have seen it too, where the submarine guy has to punch in a key and the second guy has to punch in the next key, third guy has to punch in the third key, then they could actually shoot the missile or whatever they need to do.
Get countdown, T-minus 60.
All right, let's do it. Insert launch key. Stand by. Launch key inserted. Roger. On my mark. Rotate launch key to set. 3, 2, 1. Mark.
T-minus 50.
So sorry about the text of it, but this is how it kind of looks like. You gotta, when you actually start it up with the operator in it, you could actually, it spits out all the keys that you want, and it tells you that, okay, you could use these keys to create the master key. So how do you unseal it? Basically, you use a Vault command, say Vault unseal, and then you pass in your 3 keys that you want to use, and then it would actually basically unseal the Vault for you. Once you have unsealed, then you could start using Vault. You could actually have this process automated too. You could use the Google KMS or GMS or whatever they call it now. So basically you use that to actually unseal it for you. So because you don't want to be manually doing all of this all the time, right? It should be automated. The keys should be stored in a secret place, and you could use that to integration with it, with Google. It also allows for rotation of keys. So you could actually rotate your keys if you want to. You just use the Vault operator rotate to actually rotate the key. And this is me actually trying to log in. You would actually, every time you log in, you actually create a, you have a token. When the init start up, you actually get you a root token. You use your root token to log in, or you could create other tokens to log into Vault. Vault is all about using tokens to log in. So you could have a user token, and then use a user token to consume your information. So Vault provides a key value store too. So you could just say, okay, Vault, please put me, using Vault, I say key value, put me a secret called my app, and the API key that I want to use, 1, 2, 3, 4, for example. For my application that I'm using, I need an API key, I'm storing it in Vault. And then I could just call it get, and I could call it delete. It's simple CRUD operations that you could do with it. It's a secret that's encrypted inside of Vault, and you could ask it to like, hey, can I have this information? So here I am actually storing, I'm putting a key in there, and then it also has some version information. You'll see it in a minute. So every time you actually update a key, you get a version 2. So you could actually go back to the previous version if you really need to. So it provides that functionality. There's also something called policies to a secret. So basically, the policies are to say that, okay, I want to set up a policy to consume this Vault, and you could actually say that these are the endpoints. Remember the paths that I talked about? You could actually use that to read and write policies to it. Reading secrets based on policy. If you try to read it, if you have the right tokens, it would give you the information. But if you try to, let's say, go to the secret/hello, it would actually give you an error saying that, hey, you don't have access right to it because the policy was applied to it. There's something called wrap token too. Basically, wrap token is pretty cool too. It's a limited time access token. It used to unwrap some secrets. So you can actually say that, okay, create me a token, but it only lasts for a certain amount of time, a time to live of some sort. And it would actually create you this token. Like, for example, here I'm saying that create me a token that is only 60 seconds long, and will give you this token, and the path that I want to read is this one. So now actually I could use a wrap token to read this information. Once I read it, the wrap token is useless. But I got my information that I wanted, and it's only 60 seconds, for example. Let's say I want to start up my new pod, and I want to provide it a wrap token so it would grab the information. You could use something like this. Dynamic secrets. So dynamic secrets is pretty cool. It allows you to actually lease a secret for kind of like the wrap token. It allows you to lease and say that, okay, I want this secret to be created for me. It's an on-demand. I'll show a demo of it. It has audit trails and everything else. So the idea is basically simple. A user requests this vault to, hey, give me a database connection string. For example, I need to connect to my database. It would actually go to the database, create you a user with a password, and then store that information in here and tell the database it's only valid for like 2 hours, and then it would give you back the information. And then now you could use that information to connect to your database. So a simple flow diagram is like, okay, Bob is the ops guy. He actually uses a wrap token, sets it up into your application, mounts it, for example. Your app starts up, reads the information and says, okay, I'm using the wrap token. Can I get the credentials that I wanted to use? And actually what Vault does is creates a user and say, what's the time to live? And returns the information. And the app can now actually use this username and password to log into your Postgres database or MySQL database or any other database to get this to get the connection string and actually connect to it. So that's pretty cool, actually. How do you enable it? Basically, Vault has this command, Vault secret enable databases. It would enable for everything. And for example, here I'm saying that, okay, Vault, write me this database, config my app, and the database plugin I want to use MySQL, Postgres, I'm sorry. And there's also MySQL and all these other databases. The roles that I want to allow, here's the connection string that I want to use, and the username and password. So it kind of needs that username and password to actually create users. You could limit the functionality of it to actually only a user that allows you to create users rather than SA or root or something. You could actually just create a user that allows you that functionality. But Vault needs to have access right to actually create your user. Then you would actually write that role into the database so that you say that, okay, whenever I'm going to be creating a user, like I need these kinds of rights to it. Basically, how many minutes it's going to live. And then in order for the application or something to read from it, you would call read me the credentials and would give you the password and the username that you're going to be using. Okay. So the demo that I wanted to show was basically a user is going to try to use Postgres to get me the credentials that I need to connect to my database. And the Vault that I'm using is backed up by MySQL. So the storage that I'm using for Vault is actually MySQL, but the database that I want to use for my application is Postgres. Because for me, I don't care about what Vault is using at the back, but I just wanted to show the example of like, you could actually mix and match. It doesn't matter what you use as a backend. In your front end, you could use any other databases that you want to use to actually make this work. So a little bit of the demo. So I just had Docker Compose running with like 3 databases, like one MySQL, I got Vault, and then I got Postgres. So now I'm going to try to log into MySQL using my app, logging in. And I just wanted to, so there's only Postgres user in here. There's nothing else in here, okay? I'm going to log out. And I'm going to ask my Vault to actually read me a credential so that I could dynamically create a credential from it, because everything is already set up for me. That I've created the Postgres plugin, enabled all of that stuff. Now, thinking of it as an app, I just wanted to say that, hey, can I read my credentials so that I could connect to the database? So I would execute this and would give me the username and the password that I want to use. Now I'm going to log in back into Postgres, and I'll show you. Here's the user. I just created the user. Password is valid till this time. So it would actually dynamically create me this user in there, and I could use it in my application or whatever needs that I need to do. And it would expire. So now let's say a hacker does really come to your system, he only has a limited amount of time to get your connection straight because it dynamically changes. That's awesome, basically. And if you have your app to automatically, your pod or your application to actually dynamically read this configuration anytime it's updated, then you have a less potential of actually somebody hacking into you. There we go. Docker environment. How many use Dockers? Most of you probably. Yeah. Wow. Great. I think it's a norm now these days. So how many use Docker environments to pass in your variables? Okay. Don't pass secrets in, please. That's all I gotta say. So basically, if you use your Docker environments, you'll be doing something like this. You'll be using, like, let's say a Java app. You would pass in your key and all that stuff, and then you would read your environment variables. And then when you run, you pass in all your stuff and run the application. So what happens in that case is basically, if I have actually Docker, I'm a hacker and I got into your system, which is bad already to begin with, but now actually, when I do a Docker inspect, I could see your API key that you actually passed in right here. When I do a Docker inspect, I could see all the environment variables. So if you had actually a database connection straight, now I got access to your database. Not just your Linux box that you have access or your Windows box. I actually could get into your database and get all your data too. So not a good idea. So the idea is for security has always been like to mitigate the risk. So how do you mitigate the risk? A simple way of mitigating is mount a file system that has the wrap token in there that is only lasting for like a minute or so, that your application could start up and pick up the wrap token and connect to Vault and get the information. That would be an ideal way to do it if you want to be. There's better ways to do it too, like using Kubernetes services and all that, which I'll go through in a minute. So Kubernetes provides you an automatic way to actually do all this stuff, because you don't want to be like, what do you mean my pod needs to get all this information? So in Kubernetes, you could actually do the application when it starts up. Let's see, where's number one? Number one here. The pod, when it starts up, it authenticates as a service account using a JWT token. Most of you would know what a JWT token is. It's a JavaScript web token. Anyways, it's called a JWT token, and actually would authenticate using Kubernetes to say that, hey, I need some access to Vault, basically. So Vault Kubernetes would actually go and validate, does this does this service account have access to Vault or not? So if it does, it returns back a token to it. So now the pod could actually get this token and call it to get the secrets that it wants to. It's automatic. You don't have to actually do anything about it. So this would be the pattern that you use for Kubernetes. And actually, this was my failure in my demo. So it kind of worked like this. Even corn and milk became fire. So anyways, just to skip this, what's next for Vault is basically Helm chart support. And you'll be able to inject Vault secrets using a sidecar. So that's pretty cool. You could use your sidecar to actually do all this stuff. You don't actually need to do, most of your logic would be shared with this. Just to get back to my first thing about Turkey again, what was wrong with it? What went wrong with them? Basically, they have sloppy data protection. Like, they had hard-coded password in their code, which is bad. And unencrypted data, basically. That's bad too. If you have sensitive information, please encrypt the data in your database. So that's pretty much it. And thank you. Any questions? Feel free to come up and get some materials, whatever you want.